Suppose I do this, I choose to integrate this. So I, EX, I keep, I get sine x, minus integrate ID. That means I integrate EX, I still get EX. Differentiate, I get cosine x. Now, then we wonder what's going to happen next. If you look closely at this integral here, sorry, I forgot to bring my laser pointer. If you look at that, you're still unable to integrate that. I say one more time, you're still unable to integrate that. Then what do we do? The trick is we do IKID one more time. I say one more time, the trick is you do IKID one more time. But I want to highlight one thing. For the second IKID, you better make sure you choose the same type to integrate and differentiate. What do I mean? That means you will do this, you will integrate this again, and you choose to differentiate cosine x. Same type as the first IKID. You all follow what I'm saying? Yes? So I'm going to do IKID one more time. I open bracket. Integrate EX, I will get EX. Keep, I will get cosine x for sure. Minus integrate ID. Integrate, I get EX. I differentiate cosine x, I will get minus sine x, right? Yes, minus sine x. Then I have a minus sine x with a minus, I become plus sine x EX. Close bracket. Follow? All got that? Now we have something special. Look, wait. Let's go down a bit. Not so. I forgot to bring pointer. No choice. Wait. Primitive a bit. Look. Now we have this. That looks exactly like this. Correct? Yes. Never mind. We simplify. You multiply the minus one in minus plus like that. You see this. What's going to happen now? You have this here, and you have this here. Looks exactly the same. What are we going to do? I'm going to move this across, and it becomes a 2 times of this. So far, so good. So, two EX sine x equals to this. I want to highlight this comment here. How would you solve u1 minus u? It's exactly the same principle. U is the unknown. You move the u across, you get 2u equals to 1u is half. Exactly the same principle. If this is your, I'm going to erase this. Let's look at this line. U equals to something minus u. This is the something. So you move across, you will get this 2 times, and you half both sides. You will get this. You get half EX sine x minus half EX cosine x. Now, then you will say, then the C, do you halve? Yes, actually you should halve. But C is just any constant. So you could have left it as C over 2. No problem, you won't be much wrong. Or you can say plus D. Can? I don't know how you were taught in doing IKID. I usually won't write let U be this, let V be this. I'll just leave it like that. I just choose which one to integrate, differentiate. I'll just do the bypass normally. All okay. Do you understand this idea? I repeat, for this kind of differentiation, or integration, sorry, you have to do 2 times. And you should be happy when you get the same thing after the second time. Follow? And this must be a minus. Can I have attention, please? Imagine you have a plus here, you got a big problem. Okay, it must be a minus. Okay, that's that. Example 19. What if you have a single function that cannot be integrated directly? That means ln x, for example. No choice. What do we need to do? I'll have a 1 times ln x. Then you ask, hey, how do I decide? How come just suddenly add a 1 there? Keep your hand forward, please. My principle very simple. If you want to come in and play with your handphone, then sorry, then you better get out. Either you go out on your own, or I chase you out. How do you know whether it's 1 times, how do you know it's 1 times ln x? Actually, I also cannot tell you the answer. I expose you to more questions, then this is one of the tricks that you can use, then we use it appropriately. Okay? So ln x is a classic example where we can use bypass like that. I just create a 1 and decide to use bypass. And obviously when I do bypass, which one should we integrate, which one should we differentiate? Very naturally, this is the differentiate one, this is the integrate one. Because I don't even know how to integrate ln x, do you? Why cannot erase? Goodness. Oh. Wait. Erase. Okay, never mind. I will choose to integrate this. Why? Because I don't even know how to integrate ln x. You all follow? Yes? Done. So I do my IKID. Integrate x, integrate 1, I get x, ln x. Can I say something? Can you, some of us when we do bypass, forget about the limits. This is integral, definite integral has limits. So you have to insert the limits here. Don't forget the limits. All right? IKID minus integrate 1 to 2 x. X is keep that. Differentiate ln x, I'll get 1 over x. Wow, nice. This is the best. Am I right? Integrate x times 1 over x is that you get 1. Integrate 1, you get x. So therefore, when you apply the limits x, 2 to 1, you get 2 minus 1. Answer very nicely, we can get our final answer. I'm not going to say too much. The moral of the story is, if you cannot integrate this directly, you create a 1 and you integrate the 1, differentiate the ln x. Follow? This is one of the tricks. Again, same thing. You have something so complicated, sine ln x. Can I say this is not sine x times ln x. This is sine ln x. Ln x is inside the sine. Follow? You actually take sine of ln x. This is not the same as sine x ln x. Oh? Make the differentiation, make the distinction. I shouldn't say differentiation in this context. Okay, distinction. So it's sine ln x. Again, you create a 1. So I'm not going to write the 1. You can write it on your own. I'm going to use IKID. This one is differentiate. You will integrate one. Follow? Is it too small? Can you see? Those at the back? Can see? Good. You integrate, oh sorry. I use IKID, okay? Wait. Pause a while. You all know what I'm saying? When I say IKID? Or you're lost? Sorry, I really don't know how you are, where you are at. Tobias? Oh, sorry, Tobias is a good boy, so yeah. Joe? Huh? Lost, Thank you. Then what you all do? I thought you all know my parts already. You all don't know what is IKID? Okay. Then I do this. Wow, cow. Never mind, read. Hey, what you all know, Okay, Tobias, elaborate a bit more. As in loss, as in. Okay, can you tell me a bit more? You don't know what IKID means. Come on, never mind, it's okay. Oh, not introduced before. Oh, so, okay, wait, pause. Let's go back to this example. If I show you this, does it help? Does it help? Oh. Okay, let's go back to, sorry. Okay, sorry, never mind, my fault. It's okay. Let's go back, example 18. Copy that down and see whether they make sense now. Okay, follow me. This one. You got to choose one of it to be u. Choose one of it to be u. Choose one of it to be dv dx. Which one to choose doesn't matter, as I said just now. Copy that down for example 18. I'm going to choose u to be sine x. Alright, later on, I'm going to differentiate sine x. I'm going to integrate this to get v. Okay? Yes? I'm going to do that. So that's why this makes sense. I will get this one. This is actually v. Ex is v. Ex is v times u. Alright? Minus integrate v times du dx. Follow? Is that better? Follow? A little bit better. Okay. So therefore we're going to, this is for the first by parts. This one is for the first by parts. This one is for the second by parts. Alright? So, for the second by parts, you have Ex cosine x instead. So you have a cosine x, you let u be cosine x, let dv dx be x. So that's why I say you choose the same type to differentiate and integrate. Follow? Then you get the answer. Okay, now if we say ln x now, this one integrate, I'm going to uncover this. This one is my u, this is my dv dx. I say one more time, this is my u, this is my dv dx. So I'm going to integrate dv dx to get my v, u, and v du dx. Okay? Ken, is that better? Is that better? Alright. There you are. Those of us who follow me, actually you don't have to write this all the time. If you know how to do it fast, you actually don't need. I would rather say that you remember this. Okay, I illustrate this. I would rather remember this I'll get ik minus integrate id. If you remember this, then I don't even need those columns there. What do I mean? I choose one of it to integrate, one of it to differentiate. If I choose this to integrate, I'll get I keep minus integrate ID differentiate. Done. Don't need to write all these lengthy things. But up to you, I'm fine. It's really up to you. Alright? Okay, never mind. Sorry. That's the problem when I take over another lecture. I don't know what was taught. Okay, never mind. 19b. So if you're used to letting something be u, something be v, let's do this. I let u be equals to sine ln x. And I let dv dx be equals to 1. There is a 1 here, which I'm going to let. So what's good? Can we please copy? Thank you. Therefore, differentiate this, which is not very nice, but never mind. You get cosine ln x times 1 over x. And integrate this, I'll get x. So what's so good? Yes? So, after this, I will get u, which is this, times v. I'll get x sine ln x minus integrate u du dx times v. That means I have a x cosine 1 ln x 1 over x dx. And you realize that this x times 1 over x cancels and you get cosine ln x. Now look up. Are we able to integrate? Look up. Cosine ln x. Can or cannot? Is it a standard form that we are able to integrate? Cannot. Then what do we do? Integrate one more time. Can integrate one more time. That means integrate by parts one more time. That means you create a 1. This is 1 times cosine ln x. We do it one more time. Which means what? Thank you. This one I apply here. I do it one more time. I let u be equals to cosine ln x and dv dx be equals to 1. Which means du dx equals to minus sine ln x times 1 over x and v equals to x again. We do one more time and you get x sine ln x minus the open bracket, sorry no space, take away this thing. Then you get uv, that means x cosine ln x minus integrate u du, v du dx. So therefore you get a minus sine ln x 1 over x times x dx. Close bracket. Very complicated looking, but never mind, it's okay. Let us try and simplify. You therefore get an x cosine ln x. This one no problem. Follow me, yeah? And then you have a minus, minus, minus. There are three minus in the end that's still for minus. I say one more time, minus, minus, minus. You get three minus. And then the x and 1 over x becomes 1. Is it x? Did I miss out x? No, yeah, it's okay. X and 1 over x. This one cancels, equals 1. Minus away integrate sine ln x dx. Now again, I stress, now you have this equals to some rubbish minus this. Oh, actually this line and this line are the same, sorry. I don't know why I got two lines like that. Never mind. I say one more time. That highlighted bit equals to this minus this. I move this across, I'll get 2 times of this equals to this. Yes? I just move that across, I got 2. Notice there's a 2. Again, this plus c, I divide both sides by 2, it will be a plus d. Okay. Almost ending. I mean your integration chapter, not the lecture. In general, you need to decide how. Can I have attention, please? Thank you. Okay, ready? Yes. We need to decide which function to differentiate, which means which one to be your u, which function to be your v. Am I right? That's the critical decision. And how do we decide? There is a acronym for us to decide. LIATE. You must also remember, this is just a guide. It's not a rule that die must follow. Okay? The first letter is the function that is most difficult to integrate, therefore you will choose it to differentiate. That means once you see log function, I will choose to differentiate that. I will let it be u. Okay? Follow? I'm not going to use it as a rule, but it's just a general guide. I give you an example. If you refer us to, say for example, this one. No need to refer to notes, but I'm just going to, for discussion's sake, let us take a look at this. If I apply LIATE, can I have attention, please? If I apply LIATE, x is a algebraic expression. That means it is A. Ex is exponential. Okay? So, I would choose to differentiate A rather than differentiate E. Follow what I'm saying? I will choose as priority, I will choose to differentiate x and integrate ex, which is what you did. Follow what I'm saying? Yes? Okay. That's all for